Today we're going to continue working with the Karel games. This is webinar 6. Webinar 6 is Coding Competitions and Gamethons with Karel the Robot. And we will look a little bit on how to use the app, but this time designing a game for programming mode. Most of you know me by now. I'm Sheila Bunch. I'm the Director of Education for Enzi Lab. And this webinar series is made possible by a Nevada State Library, Archives, and Public Records Continuing Education grant funded by the Institute for Museum and Library Services through the Library Services and Technology Act. NC Lab is a self-contained desktop platform where you can learn and use computer programming, modeling, and many other STEM skills. We have a bunch of new courses that we're working on. It'll be very exciting to announce those in the not too distant future. And the way Enzi Lab works is that you learn through self-paced, self-graded courses. You apply those skills using the apps. And in this presentation, we're going to think about how we can engage people in programming through competitions. So I'm going to look a little bit first at different types of coding competitions and hackathons, and then we'll learn how some of the elements of setting up a competition using Karel, ways to build challenges and earn points, and we'll use the game editor to create games which require programming to solve. Last time we really focused on games that you would solve in manual mode, and how to use some additional features, including translating your games into another language. Finally, we'll look at some ideas for setting up a club based on the idea of these competitions, or a camp. Okay, so some general concepts around coding competitions. They are timed events. These can be single events, they can be tournaments, they can be longer term contests with deadlines, but regardless, there's a beginning and an end to them. They're often based on a theme or a general problem, and that's definitely at the heart of hackathons. Hackathons are usually based on a fairly generalized problem, and then individuals or teams work on solving them creatively. The whole purpose of hackathons is to think a little bit outside the box, come up with some new solutions. Coding competitions are usually divided into categories, so you can enter into more than one category. And they're also leveled for difficulty, often leveled for age or experience, and they can be set up for teams or for individuals. So I decided to pick out 3 competitions that are fairly common here in the US and also abroad. And the first one is Skills USA. If you have someone going through the Career Tech Ed program in the high schools in Nevada, one of the requirements is to participate in Skills USA in whatever category they're studying. There are actually different organizations for different types of skills, but computer programming and CAD and things like that fall under Skills USA. Another competition is the Computing Olympiad, and it holds national and international events. It's serious. It's a big honor to win that particular competition. And then we have Major League Hacking. This is a large network of hackathon events and activities. So we're going to take a quick look at their websites, and I put the links in here so you can use them. So this is the Skills USA website, and there's just a ton of information on here. You can collaborate with a school, help train a participant, and I'd recommend that. Get in touch with your local schools, especially if you're interested in training someone for Skills USA. The Computing Olympiad, again, this is more strictly computing. You can see various winners here. One of our clients in Mexico did very well in the Computing Olympiad, and they did it primarily learning through Karel. So this shows you what Karel can do. And then this is Major League Hacking. That's their website. And it says each year we power over 200 weekend-long invention competitions that inspire innovation, cultivate communities, and teach computer science skills to more than 65,000 students around the world. So these are all fairly well-known events, and I know the libraries are learning a little bit more about hackathons, which of course extend beyond just mere programming. This is applied problem solving. So what can we learn from these guys? Well, these types of events prepare kids or people or whatever for the job market. A lot of job readiness skills. You'll see that especially in something like Skills USA. They are expected to present themselves professionally and dress professionally. And so this relates again to this job skills chart that we looked at a couple of webinars ago on hard and soft skills. You can also build experience for larger events. So these are all staged. They usually have some kind of local event, and you work your way up to state, national, and international competitions. You can not only show off your skills, which is the last item here, but there's a lot of emphasis on interacting with the program, debugging, how to evolve it from something simple to something applied or complex, how to improve, and build a community with other coders. And that's especially true of the hackathons. They all have tiered problems. The Olympiad uses platinum, gold, silver, and bronze, and there's some great examples on their website of the difference of difficulty in those problems. So again, if you have a library patron or a student, if you're collaborating with schools who wants to train for these competitions, once they get their feet wet in programming and learning some logical reasoning, they can basically continue on and practice their skills at these levels. So it's interesting to look at how they judge their competitions. And these are the main points from each one. I didn't put the Olympiad in because we're going to look at the document. It's a doozy. It's a very tightly controlled set of criteria. But for the hackathon, they're looking for technical complexity. So if you solve something, they want to see how deep you're going to go and how completely you've solved the problem. They're looking for polish. So is it finished? Is it just very rough? They're looking for originality. Have you really tried to do something different? And usefulness. Can it be used in the real world? I love those criteria. These are very real life, and it explains why these have become such popular events. Skills USA, again, they're trying to train people for the workforce. So they're looking for skills that we would want to see in a programmer or anyone for that matter who's employed. You want to see that the work is complete, that the output is correct, that they have validated the input. In other words, you see evidence that they actually have used that information and solved the problem according to the criteria. They're well documented, so someone else can use the code. The code works efficiently, and the overall quality of the work is good. So something you wouldn't be ashamed of presenting as part of your business or your department. So let's take a look at the Olympiad's criteria. Okay, so I'm not going to even try and read this, but you can see that it's highly specified. So again, that link is in the slideshow. And if you have someone who wants to train for it, it's important to read their criteria so that they know what they're up against. The Olympiad is very much a solo competition. In fact, you're penalized if you have any help from anyone else, whereas the hackathon it encourages teamwork. And Skills USA, very often the students will go as a team, so they're representing their team, not just as an individual. Of course, the Olympiad, as you saw, there were pictures I'm sure those kids travel in groups and train together too. So Karel's a game, and we're not going to get quite as serious as these major competitions, but this is a great way to introduce people to the idea of competition, and we'll call Karel's hackathons, we'll just call them gamethons. We're not solving a real world problem, although we possibly could simulate it, but we're creating games and trying to improve them and come up with something original. So that fits the spirit of a hackathon. These are some attributes of Karel that I think are really helpful for people who are just starting out. Karel uses native language, so you're scripting in English or French or Russian or Spanish or whatever the case may be. So that's a familiar link to your regular everyday speech. It has a graphic output, so you can immediately see the results of what you've coded. It has a built-in editor, which is quite easy to use once you know how it works. Karel's also very inclusive. There's lots of themes to choose from. It can make you feel at home, choosing a theme that's comfortable, and it provides language support. So this is good for people who are perhaps English language learners. And it's exploratory, so you can start very simple, but then you can build in complexity and depth and some pretty sophisticated logical structures and programming skills. So here's just some examples of the backdrops in games. These are out of the course. There's a desert scene with scorpions and a mountain scene with snow, and we've got this sort of Indiana Jones style tomb with golden masks that they're mapping out. We have a factory with oil spills and barrels full of who knows what. We have a pretty little garden here with water and flowers, and we have something that looks very dungeony with skulls and fire and stone fortress-like walls. So you can make it entertaining. These are a couple of screenshots of what it looks like in Spanish. You can configure your desktop so that all the language attributes are in Spanish, and you do that from the little settings box in the lower left-hand corner. You just set your language to Spanish, and then it will reload the desktop and all your text will be in Spanish. And then within the game itself, you can set your commands to Spanish, and you can see it's avanza instead of go, and llave instead of key, and so forth. So how do we differentiate for ability? We know that some people are going to come in and really they're only going to be able to manage the most simple game, and there'll be other people who need a challenge. Well, one of the techniques you use when you're differentiating is to come up with a very simple problem, but then solve it in different ways. So I just threw an example up here. Karel has 60 roses and must fill 5 baskets. That sounds like a 4th grade multiplication problem, or actually 3rd grade, but I'll show you in a moment here how that can be expanded. We could have categories, for example, that are based on code structures. You could enter a category that just creates a manual mode game. You could enter a category that created a game in programming mode, but only using the basic commands. And of course, those are go, left, right, get, and put. So the 5 commands. You could get into a category that use those commands plus repeat loops. So now you're looking for repeating patterns. And that would be anyone who's studied the course to the end of Unit 1. That's where they learn how to use the repeat loop. You could have a category where you're using the basic commands, repeat, and then the 2 conditions, if else and while loops. That would bring you to the end of Unit 2. You could have a category that used defined commands, which you learn how to do in Unit 3. And then I jumped ahead a little bit. You could try building a maze that can be solved using recursion, which you learn in Unit 5. And there's all kinds of other possibilities. These are some suggestions. All right, so I mentioned that we can expand this idea of 60 roses and filling 5 baskets. For example, you could collect roses from an array. Now they learn the algorithms to solve arrays in Unit 4. You can solve an array from any starting position. They could collect randomly placed roses. This can be quite a tricky problem to solve. They could collect roses or tulips, so now you have two different items. They could avoid spiders. We have an obstacle. You could create a walled garden with one exit, use a wall following algorithm to find the exit. You could map the locations of these items, roses and tulips and spiders. That's creating Python lists. You could, again, just as you could randomly place the items to collect, you could randomly place the containers or put them in patterns. You could select to put roses in the baskets and tulips in the boxes, and you can do that by giving the container that attribute that will only accept one or the other. You could assign different capacities to containers. So you might have a container that can only contain one item and one that contains 12. You could add some calculations, print out price lists for your flower baskets and boxes. And you could perhaps start with a random number of roses and then fill each basket with a dozen roses until less than a dozen remains, and so forth. You could create some variations on a problem that provide different challenges, and then these are ways to earn extra points. We also want to assign points for code quality. One way is comparing different ways to solve the same problem. And this would be in the simplest form. You might compare runtime. How long does it take to run the program? Because sometimes you can't always tell just by looking at the code. You can have a code that has very few lines, but it takes forever to run. And so it's not necessarily the number of lines that dictates how long a program runs. If there's a lot of calculations that go on in the background, it'll take a long time. You could compare the number of steps taken, operations, or lines of code. And if you've been through the course, you know that students earn bonus points for writing the code in less lines. You could make sure that if it's a program using conditions, then that's if, else, or while, that you test it on several mazes to see if it holds, especially if the students provided you with several mazes. You can check for clear and useful documentation. This includes comments in the code. It might include print statements. It could include a good description on your coding screen. It could include the solutions. There's a lot of ways to provide that documentation, and that's, again, developing job skills. If you've ever come in behind someone's code that just coded stream of consciousness, thousands of lines of code with no documentation, you'll appreciate how important this is. You also want to look for clean organization and structure. So that's the appropriate use of code structures and defined commands, and code that can be tested and debugged easily. This is something they learn in the course, and you want to see it in their code. All right, so it's not just the business of computer programming, we're also creating a game. So I've started it out with a want ad here. Wanted game with good looks and personality, easy to get along with, no boring games, please. Well, that's basically how people interact with the games. They're not too interested in all the coding behind the scenes. They want to know if it's fun and if it's going to keep them engaged. So these are different types of attributes. It doesn't sound exciting, but that does mean including instructions, objectives, and rewards. And those rewards could be points. Then, yes, they can assign points. Or it might be a type of print statement. And some of the classic beginning coding games involve random outcomes that produce different types of statements. So it's almost like the 8-ball, you shake it and put it on the table and it tells you fortune. So rewards don't have to be extravagant, or you can create rewards with print statements even. An engaging storyline to make you feel like you're doing something in your imagination. Graphics, that's using the pre-made items in Designer, but in a way that's pleasing and that makes sense and that relates to the storyline. And yes, students can add tutorial pages, just the way we do it in the course. But this is where you could put in some fun artwork or photographs or a story or even a video link to a little YouTube video. Too far there. It's nice to have a coding template available, so if the game is a little difficult to solve, they can click on a coding template and fill in the blanks and feel some success. And then if you're working, say, on a team competitions, you might even work together to build levels in a game. So you have level 1 being very easy and so forth, just like you would in a video game. They always start out easy to teach you the ropes, and then they add skills or powers or whatever the case may be. So just in summary, keep the level of difficulty as a category so that this gives you a lot of potential to win in a category. And you might include age subdivisions, so you might have a manual mode only category, but then have 3 age subdivisions, and then choose from those for an overall category winner. You want to make sure that to get points that the basic challenge has been solved. They can get extra points for including extra design elements that support the basic challenge, for their coding and documentation, and for adding some nice game elements. You want to keep your scoring guide very simple, a rubric score 1 to 3, and maybe a place on the form to write in a comment. Comments should always be encouraging and constructive and brief. Just a little something to send them on their way with some thoughts on where to go next. Hackathons in particular are often peer judged. It's almost like a science fair. You can have participants present their projects, and so everybody walks around. You might hear a little presentation or try out their device, read their documentation, and so forth, and then they can try other people's as well. It's good to include some time for presentations and sharing, and you might have some fun people's choice type categories that people can vote on that address, say, humor or simulation of a real world situation, good storyline, some elegant coding, or just a very polished presentation. So let's work a little bit more on the app itself. Last time we really went through the maze design and a bit about creating a manual game. And there's quite a bit of difference between creating a manual game and a game that's solved in programming mode. We'll start by just reviewing what we learned in webinar 1. It's been some time. And then we'll learn the features that are used to create games for programming mode. In manual mode, you're looking down on the board. You're the human in charge. This is a very neat analogy to real-world robots. So you're flying with a remote control device, which is your mouse or your buttons, and you can see the end, you can see where all the obstacles are, you can see where the items are, you can count your steps ahead of time. It's very much the human that's in control. You have the bird's eye view, and you can make those decisions as a human on how to manage the task, avoid problems, and meet criteria. Your setup can be pretty complex, random, whatever, and you'll still be able to solve the game in manual mode. Programming mode, it's not the human that's running the maze anymore, it's the robot, and the robot is only doing what the program tells it to. It also has a very different view of the maze. So you think of yourself as if you're Karel on the maze, all you can see is what is in front of you or detect what's underneath you. That's it. Otherwise, you're blind. So all actions and decisions are based on logic defined by the program. Think of real life. Automating a process requires a lot of work to do even very basic steps. And it's the same with creating a game in Karel. You're learning baby steps first, and then maybe you can elaborate them. So yes, you can have a messy, complex maze, and that still can be solved in some way in manual mode, but you're going to create yourself a nightmare if you start out with a messy, complex maze in programming mode. So if you have a maze you really like, you might want to save a copy of it and then start cleaning it up to try solving it in programming mode. Expect to simplify it, organize it, move the elements around so that they form patterns, and especially patterns that lend themselves to program solutions. You're definitely going to reduce the quantity and types of objects, containers, and obstacles. You'll simplify the tasks. You might not have 5 tasks you do in the maze, you might have 1 or 2. And you can always build complexity back in later. So once your maze and your program are working nicely and reliably, then you can add some elements. All right, so let's review some of the editor and designer features. Again, you get to the app by going to Creative Suite and then Programming. And Programming gets you to Karel the Robot. And this is the default screen. It has a little bit different maze at the moment, but it's basically the same. It opens up in programming mode and it shows you some sample code which you can step through to see what happens line by line, or you can run the whole program to see how it works. You can also run the same maze in manual mode, and this is a great way to just become familiar with the controls. Just run the default maze, and there's your buttons to press and use the 5 commands. And then you have the fun of creating the maze itself, and that's in designer mode. So when you get to designer mode, you have menus and objects that you can select and use to create your maze. It'll prompt you to save your maze. You can save your maze as a maze file and then convert them to games. You can use the same maze to create different games, just rename them. Here's the menu bar that you use to create the maze. You can select a theme. You can select obstacles, including a large number of walls. You can select collectible objects, containers to put them in. You can remove objects one by one or erase the entire maze. You can redo and undo, and you can turn Karel left or right to orient him differently. And you can move his starting position, and you can also move the home square. And there's a little video link there if you want to see better how to do all those basics. Next, you convert the maze into a game using the Convert to Game button. It'll ask you to save it as a file. And now you have a new menu to work with. And I did notice that the student menu looks a little different. They don't have a pages tab and they don't have a solution tab, but we're going to add that for students. You can still create pages using this summary tab, but you have to open it up every time. So we want to make it convenient and put in a pages tab for the students. So this is a text editor, and this works whether you're creating a manual game or a programmed game, a game that's solved by programming. You write your text here and save it there. And then in manual mode, you have some limitations on what you can do, but you can dictate the number of steps, the number of operations, how many objects to collect, whether you need to collect all the objects. You can create a custom victory message, and you can select whether you're going to fill all containers, whether you're going to finish on the home square, or where you back to where you started, or at a specific position on the maze. And here's an example created from those 2 screens. The story appears up here. We put in that it's going to take 54 steps and fill all containers and finish at home. So those conditions appear here. And we said that it's going to be solved in manual mode, so it brings up our manual controls. Once the game is solved, we get a nice little message that we've saved the day, and it provides us with data at the bottom here on how we did with our game. All right, so these are shareable. You can make a URL link and you can dictate whether someone can view it, someone can view and run it, or they can view, edit, and run, which the third option you would want if you're working as a team. You assign privileges there. We are going to tighten up who gets to run these games, so I put a notice here. They'll no longer be as shareable in the outside world. The person viewing the file will have to have an NC Lab account, and that's easy enough to create. You can create a free account on the website homepage, and then you can run the game in your desktop. And yes, the links can be shared. It can be shared in a document. It can be shared by email, by messages. There's all kinds of ways to share the link. All right, so this takes us to programming mode. So instead of manual up here, we've selected programming. And now we can also assign points. So this is something you usually come back to after you figured out a good solution for the program. And this is a hierarchy, so it goes from the most number of lines to least, and the least number of points to the most number of points. So in this example, it says that if you solve it in 20 lines of code, you get 10 bonus points. If you solve in 12 lines of code, you get 20 bonus points. And if you manage to get it down to 6 lines of code, you're going to get 40 bonus points. You also have the opportunity to write in required or forbidden keywords. So if you, for instance, you want to make sure that they're going to have to create a defined command to solve the problem, then you would write DEF in required keywords. Just so you know, there are some suggested words in here, and if you see them grayed out, they're just inactive. It's just showing you what you can put in there. Active words are going to be in the black color. All right, going through the other tabs. So this tab right now, as I said, for some reason, it's not in the student version, but we'll put it there. And it's a good starting point for these other tabs, which already exist. If you have your solution here, it's easier to create your initial code and your code template. While you're debugging the game, it's good to have a text file app open, such as Notepad, where you can cut and paste your code into it. It's just strictly text, and that way you have a record of it as you're going. You can save different versions, and you can always plunk them back into the program. Those text files work just fine. Once you have the solution that you really want, you can put it here. Students who are studying for the advanced placement exam in high school, they're expected to provide their code to the evaluators. So this is a nice way to do it. It's right here in the tab when they give them the file. And it's just handy. You can use it for all kinds of purposes. Initial code, that's the second tab, and this would be code that you would always want to show in the game, and you can just write it here, and then when you run the game, it'll stay here. Now it can be overwritten, but it cannot be erased, and that's really nice. So if someone erases the code, this won't disappear, it'll still be there, and that's really helpful if, for instance, you're providing a list that they're going to use, or just some other information that has to stay in there, or maybe it's a really difficult program, so you want to give them a little bit of help to start with. And then you can go to a full code template, and people use these in the courses when they really are puzzled, they can't figure out how to solve the game in the course. Then they can click on this question mark, and that pulls up a template. Well, that's nice for your game players as well. Again, if you have the solution here, you can cut and paste it into here and replace all the keywords with ellipses, which you'll see these turn blue, so they're actually recognized as a sort of a keyword. So let's go back to our text editor. What's known as the summary page is just the text that appears at the top of the screen on the same page that you write your code. And you can just overwrite this. This is what you call a WYSIWYG interface, so what you see is what you get. You can actually pull up the HTML if you want to see what's going on. you just click on the source code from the view menu. This is the view menu here, and you'll see this in HTML. I'll have to tell you that's really nice when you're importing text from somewhere else, because usually if you cut and paste text in, it has its own code, and you can actually clear that format and format it the way you like it. Once you have created your summary page, then you can add pages, and that's just this plus button here, and then you can put them ahead of the summary by clicking on that arrow, or after the summary. So once they've completed a game, you can add a page there. This is where you can start developing some story to the game. To create a Spanish version, you'll see this will pop out. There's a double arrow here, and you'll see a flag, and you click on that, and this is where you write your Spanish text in. You can start, if you're doing a bilingual game, you can start by copying the English version. There's just a little button here that'll copy the English in, and then you can overwrite it in Spanish, and the results work. So if your desktop is set to Spanish, then you will see the Spanish text. If it's set to English, you'll see the English text. So it is possible to create a multilingual game. Images, these you can add to your game in the additional pages, or even in that, on that summary in the above the text above the code, you can put an image in there. But first you have to import it into your cloud folder. So you go to, and you know what, I should open my desktop to show you that live. Be a little easier to see. All right, so you go to My Files, and this is where we're going to load from disk. So you bring the file into the My Files, into your My Files. So I can select a file, and I'm just going to pick this drone here. So now I've selected it, but now I've put it here, but I have to select it now. And then I am going to press this green arrow, and that will actually load the file. And now once this green check mark appears, I now have it available to me in My Files. So I'm going to go back to the slideshow. So once you're successfully loaded, so there's your 1, 2, 3 steps, then you can link to it. So you open My Files, you select the image, and you'll see there's a file name there from the folder, and there's the image in your editor. Just so you know, you can do this from another repository with a URL link, but I think it's simplest to just do it from your file folder. All right, so let's think about how we can do these competitions. And basically that was it. That's all there is to doing a game in programming, is you just select programming instead of manual. You have a few features available to you that aren't available in manual mode, but definitely the cautionary note, start very simple with fixed patterns that you can solve through a program. All right, so if you have a club, think like sports. If you have, say, a soccer league, you have frequent practice sessions, and then you have casual games, and maybe eventually you go into a tournament of some kind for prizes. It doesn't happen all in one fell swoop. So this is what I would recommend, that you set up practice sessions and use the course and the projects to learn logic and skills and practice game building. And then if you have someone who would like to enter one of these more serious competitions, they may pick some criteria that they want to work on, just like an athlete training. And that's this think ahead part. So if you want to do a certain type of skill in a competition, backtrack that and plan what you need to learn to get better at that skill. If you do an event, really bring in the community. You know, just like you'd have if you hosted a soccer tournament, you'd have parents bringing snacks. You might have businesses contributing prizes. Someone's got to remember to print out all the ribbons well ahead of time. So this is where you bring in your volunteers. They can work on publicity. They can work on food and refreshments and prizes. And something that was noted on the hackathon site was that non-cash prizes are better. They're more memorable. If you get money, you just spend it and then you forget about it. But some cool little prize, and I know my daughter still has her little stuffed cows from 4-H. It brings back some good memories from the state fair when it still existed. So this is a recommendation to go for non-cash prizes that are fun. You'll need people to be mentors, to be judges in the competition, to be chaperones, especially if they're younger people, to help organize the event, to do fundraisers, or you may do your event as a fundraiser. And sometimes people will participate in an event because it's raising money for something else. I'm sure a lot of people would never run 5 or 10 Ks unless they were raising money for cancer, for example. So you can think of fundraiser possibilities for the library or for other causes that will draw people in. You need people to help set up and take down. There's lots and lots of jobs, and bringing the community in, I think, is good for the library. You could also do it as a camp, and here's some suggestions. And most of my camp suggestions go back and forth between offline and online skills, and they rotate through in a spiral. But because this is a competition, you're going to need a lot more time just for rehearsal. So you want to make sure they're set, and really I'd recommend this as not the very first time you get exposed to Karel, but say they've been to a Karel camp before and they've at least done Unit 1 and they're working on Unit 2 or higher. That's when you would, I think most of them would feel more comfortable with that experience behind them. So session 1 is where you register, explore the app, make sure you know how to use all the features, and then they would work on the course to gain some skills. Then I really recommend a break where they play some games. These could be board games, they could be sports, they could even be other video games, just so they get the flavor of game structure and rewards and what's appealing to build into their own games. Go back and pick up some more skills in the courses, and then you really need some time practicing creating Karel games. It's a lot harder than you think. You need to practice. I spent a few hours creating a game that it was pretty rough, put it that way. So you need that time. Then it's good to do a rehearsal, just like you would rehearse a play or an event or just a pickup game. Go through a mock competition, and it gives you an idea of how much you can do in the time period and what kind of flavor you're going to add to your game if you're going to do it as a team and so forth. Then you need a little bit of review, reflection on that experience and planning some strategies on how you're going to do the main event, and then hold an event and make sure you have time to celebrate the results. So you could start really small in the camp setting. You're not going to have very many people. So this whole thing really is kind of a rehearsal for more of a community event. But this is, I think, a very good experience. Okay, so what we covered today. Well, we learned a little bit about some of the big guys, the coding competitions and hackathons that are out there. And I hope you explore those resources. I certainly learned a lot from them, and I'm sure you will too. And again, I know some libraries are doing the hackathons, so please talk to each other and learn from each other's experience. And same thing with the schools in your neighborhood. Some of them are doing Skills USA. You can learn from them and maybe even collaborate with them with their teams. We learned a bit about how to set up a competition and way to earn points and how to structure categories. We learned a few extra things in the game editor pertaining to creating games that require programming to solve rather than manual mode, and how to translate a game, a little bit more about the text editor. And then just some suggestions on how to set up a club or a camp based on a competition. Okay, as always, and I hope you've been going to this. These webinars are posted. This slideshow is available as a PDF. Any kind of supporting materials I can think of, I either create at the time or add to the site. And please ask questions there, because this is how we improve what we offer and how we support you the best way we can. Oh, smallest group of kids to run a camp. Good question, Matt. You know, I think if you were going to have a very small group, you might think of them as a potential team that would go to a competition, so that they're working a little bit competitively, but also collaborating with each other and coaching each other. And when it comes right down to it, a team of two that's two people. You could probably do this just with two, just like you would play a board game with two people, and then scale up from that. So yes, I would say you could have as small a group as two. And what might be fun for them is also to think of them as training as camp leaders. So if they get the feel for it, then they might run a competition themselves. And you know, you can also always bring in another community group, such as Scouts or the Boys and Girls Club. Sometimes this can be tied in with their activities. I know some of the libraries host groups such as those. And again, think of fundraisers. You know, boy, Red Cross, that might be something really cool. You can even do medical themed games, because we have the backdrops and icons for them, and we're going to be adding to that. I thought about putting together some kind of just a scoring sheet, and if you're interested, I can post that on the community page. I think that would be helpful. I can do it as a spreadsheet, so you can change it up as you like. How often should a camp or class be held? Well, okay, again, I'm thinking about sports. When kids are training in baseball or soccer or volleyball, if you're really training for a tournament, it has to be more often than you would normally do, say, just a coding club. Usually those kind of team sports are held, you know, over a 6 to 8 week period, 2 or 3 times a week. And again, this is where volunteers are really helpful, because I know you guys you have limited staff, but it's something to think about. If they have a goal in mind, if they're going to hold a tournament, then I would suggest maybe hosting, at least using the library to host with volunteers, some kind of training 2 or 3 times a week leading up to that. And then they'll really be ready to do something impressive. Oh, can you think of anything else before we go? Okay. All right. That was a firm nope. That's fine too. And again, community page, if you think of anything at all, please post it there, and we'll do our best to answer questions. Until next time, bye for now.